Welcome back to Element 14 Presents. I'm Clem, and in the previous episode we made this universal debugging screen. And I want to turn that into a kit, but instead of showing you the boring process of redoing the same project over again, I'm showing you how to leverage manufacturer-supplied data to streamline your process and get it out as fast as possible. Let's get started. This is my universal debugging screen. I made that in a previous episode, so I'm not boring you with the details, but this allows you to look at serial buses, no matter which one, in the way that you would use a multimeter. So you just plug it in and you see exactly what's going on there. A handy little tool, but this form factor is not handy at all. So I want to redesign that into something that you can maybe assemble as a kit or get as a ready-made product, including the case. And because it is too hard and too cumbersome to 3D print all the parts every time somebody wants one of these, it's usually much more professional to use ready-made cases and modify them. That way you can easily make not just one, but a lot of them, and cost-wise you should also be on the better side, especially if you need certifications and stuff. Especially if you're doing measurement equipment, using common cases is quite common. So these are all made by Hammond Manufacturing. These are hand cases that have overmolding on the side, so they are really pleasant to hold in your hands. These are made for handheld devices, and they also have removable panels. So this is where I put all the inputs and outputs. And I decided to use this one because A, it's blue, and B, it has a battery hatch. But I don't want to use that as a battery hatch. When you're using a multimeter, you always have cables because you, of course, have to attach to something. And the way to store them is usually like this, and then clip them in over here, which is handy, but it's not ideal. And for my device, I will also need some cables to attach to the device that you're testing. Maybe have even individual adapters, so you can adapt it to whatever device you need it to have ready-made plugins, basically. And I want to use the battery hatch, not to have a battery in there, but to store the cable that you need, so you have everything handy. I have my case and I have a project. Now case. Okay, we have to make that fit into that. So my first step is to decide on a few alternative parts. So get rid of some of the old parts that are used in a project, supply them with new ones, and try to find all the data for these parts. So the data sheets, I want 3D files, preferably step files, because I can easily manipulate them in my CAD system, which is FreeCAD, and then put them all together and see if they fit. And turns out that Hammond Manufacturing not only has great plans that show you a detailed PCB outline, so you can easily trace that, recreate it in FreeCAD, then import into KiCad to make your PCB design in the perfect shape for the case. They also supply step files that are separatable. So you can get away with all the components, you can split them however you need, and you can modify in there. And if you produce a lot of those, then you can take these files, give them back to Hammond, and they will do the cutouts for you when you go to mass production. And as long as you're producing a few, you just make the cutouts yourself. This is what we are going to do. So I've traced the outlines that were given to me by the manufacturer in FreeCAD, imported that into KiCad, made the outline shape from it, and then designed onto that. The basic functionality is the same. I just moved from an ESP32S2 to an S3 because of availability. I've added a rotary encoder instead of the buttons, so it would be easier to navigate the menus and stuff with just one hand when you hold the device in your hand. And I've added some buffers, which should allow this to be 5-volt tolerant as well. And if you need a 12-volt system that you're looking into, like RS232 or RS485 or whatever, then you just plug in an additional module that does the voltage conversion for you. So this is basically an expandable system. I've got the PCBs made by Isla, of course. They are gorgeous as always and came really fast, and they fit perfectly into the case. Let's try that. In my quest for alternative parts, I came across this 1.8-inch TFT screen. This turned out to be cheaper shipped, including an SD port on this module, than buying the bare screen directly. So always be aware on how to source your parts. Sometimes you find the same part used in a module and can use that. And now I'm using Patafix, which is like this rubbery glue thingy that's removable. You use this for posters and stuff, to fix that exactly in the right position into the case, and we can see if it fits. KiCad allows you to view your finished PCB design in 3D, but it also allows you to export it as a step file. Be sure that you have your settings right, so it replaces all the WRL models with step models that you can also supply to KiCad. And then when you export it, all the individual components are there. So if you import that then into FreeCAD, by the way, there's I think a plugin that allows you to directly push it, then you can individually turn on and off all these components and move them around even. So if you are encountering an issue when you assemble your project into FreeCAD, so when you use the case, put the PCB inside, add all the components and stuff, then you see, oh, there's some interference, you can just push it there, move that back to KiCad, make the changes with the traces and stuff that you need, and then go back. So these push and pull workflows, they also work with open source tools, not just the expensive commercial ones. So in that case, we can easily check if the parts fit just because the supplier gave us really good design files. Some of the suppliers don't give you those design files, but you can find a lot of them online by just using the part number as your search query and like go through all the databases, and you usually will find a lot of them. I, for example, found the encoders in a lot of different versions on there, and even those pointed me to a specific type of encoder that I then used into my design. So sometimes looking for the right step files also leads you to the right parts for your project. I recently also learned how to add textures to 3D files in FreeCAD, so I put my logo on there, but in reality on this surface of the case there will be a pre-made sticker that also covers the screen cutout, so you are not able to like pinch it or damage it. And it will also have like some writing on there to help you navigate the menus and stuff. So this is basically a decorative layer, which is just a sticker, but you can also fabricate like complete keypads in that way and just stick it on there and feed the cable through a little cutout. So the options are pretty much endless, and this is the professional way to do it. It has some investment, but in the long run, this will save a lot of money when you're producing stuff. You could now just 3D print your design to make sure everything fits. I recommend resin printing for that because you need a very tight accuracy, and also the shapes that are involved, usually with injection molded parts, are a bit more complicated, so it's easier to use resin printing for that. Of course, use a resin that is fit for the purpose. You know which one I'm gonna recommend because it's the obvious choice. It was made for exactly that. But in this episode, we're going to modify a case. Like this is exactly how it comes from the supplier. And we design a jig to make sure that it is held perfectly in position when we put that into our modification machine. And we're trying out 3 modifications. We're doing fiber laser, CO2 laser, and milling.
Hello, I'm James from Workbench Wednesdays, a show about the stuff found on your electronics workbench. Look for new episodes on, well, Wednesdays. You can connect with me over on the Element 14 community. I look forward to seeing you. For now, it is time to get back to watching this week's project video.
So why are we bothering with multiple ways to modify the case? Because it's not always obvious which one is the best, and you always have to experiment. So never get just one case, get a few, do experiments on them, and then you can decide which way of modification is the best for your project and for the material. Be aware that some materials can be cut with a laser cutter, but they will off-gas toxic fumes, like polycarbonate should never be cut with a laser cutter. ABS also can put out toxic fumes, but you can filter them out if you have the right filtration system. So be aware that there's always a risk involved. In milling, there's the risk with shooting your parts around because you didn't fix them right, and in laser cutting, just laying them flat in and maybe using some magnets to keep them in place is enough for them to be mounted. So laser cutting might be the faster option. Milling can in some places be the only option. During these experiments, I'm of course wearing my insect goggles. These are real professional laser goggles. These are expensive, so if you're working with a laser, get the real stuff, because your eyes can't be fixed if they are damaged once. Very quickly we can see that fiber engraving is like perfect engraving. It does a really good job with that, but it's not so good for cutting. We would need a lot of cycles to make it go through the whole material. And usually these sources are pretty expensive to run, so I wouldn't recommend fiber laser in that case. I've googled around and turns out that these ABS cases could be better cut with a CO2 laser, but also be aware of fumes. So the next thing we're gonna try is CO2 laser. But we already figured out that for making writings on there, the fiber marking laser, that's the best option. The next system up is CO2 laser cutting. This is a really big machine, so you can fit a lot of parts at once in there and have a job running across all of them. So you can maybe like do 20 cases at once. But be aware of the fumes, and that is why we have a big professional extraction system over here to have proper filtration. CO2 laser cutting was a bit tricky. It did the job, but also if you don't have the settings perfectly dialed in, it will accumulate some heat, and therefore the edges are not as nice as I would like to be. So I'm using the little mill to make another experiment and see if milling is the right option for me. To be able to mill in this machine and to get an accurate position, I had to make another jig. This is pretty simple. It screws onto the machine. When it's completely homed at 0, 0, it will reference this point on the template, and the part gets just screwed in to the other side, and then they are both mounted into the machine. I've used a single case for doing all my experiments. As you can see, some did cut really nice, some not so much. I had a bit of heat accumulation, especially in the CO2 laser, and in the milling machine, while this looked perfectly fine while it was in the machine, turns out the parts shifted a little bit because of the forces involved. So you have to have really tight and toleranced mounting to make sure that everything is square, and this one ended up a lot not so square like the other experiments. So I think for my particular use case, CO2 laser with proper filtration and a well set up G-code for that and well dialed in settings, so I will have to run a few more experiments on this, will be the right way to fabricate that. Keep also in mind that you may need to do some additional works. Turns out that the front plate here, that can't stand so much heat, so it actually melted the little mounting holder that I had for it. Yeah, so this isn't really so much modifiable with a laser because it's just too thin. There's just a little mass to absorb all the heat. But this is just a flat plate with cutouts, so I can also get that made as a PCB alongside my main PCB. So there is always an option for flat panels that you have to have very tight tolerances on. The data that I got supplied from the manufacturers allowed me to make a thing that fits on the first try into my design. And now this is basically usable with one hand, no matter if you're lefty or righty. And it's like a pretty sleek package, and I still have this here free, so I can package in the cables that you need to use the device and have the battery mounted in this cavity here, where it's not usually supposed to go. I have a bit of an interference issue with the screen, the SD card slot and the connector here. And that is basically the difference between CAD and reality. Like in CAD, all the things are straight, everything is perfect, everything is mounted in exactly the right way. In reality, there will always be some issues. So you have to have a little bit of tolerance always. So never rely on something fitting perfectly in CAD, because in reality it can just be a little bit different, which ruins all the things. So we'll have to make a little adjustment here with the positions to make sure that everything works fine. And also on the board I have 2 versions of power supplies, so I can with this iteration experiment, do I really need a switching power supply or is an LDO good enough? We have turned this hobby project into a thing that could be a kit or that could be even manufactured by leveraging the data that suppliers give us to make sure that everything fits, design custom PCBs that perfectly fit enclosures and even modify them. So once you go from a few pieces to mass production, you can just use the same data over and over again. Connect with me on the Element for Clean community, and I gotta go. There's another project waiting for me.